Good morning, sir. Myself Sunil Malav. I am a student of Engineering College Jhalawad from Computer Science and Engineering Department. Today I am presenting my industrial training presentation on machine learning to Sachin Pal, sir. This is my industrial training certificate on machine learning. I have completed my machine learning industrial training from Udemy online platform. This training is complete about 25 days. In third slide, machine learning history. According to Arthur Samuel, in 1995, Arthur Samuel defined machine learning as a field of study that gives computers ability to learn without being explicitly programmed. And the goal of machine learning is to build computer systems that can adapt and learn from their experiences. This according to Tom Dietrich. In fourth slide, what is machine learning? Machine learning is a category of an algorithm that allows software application to become more accurate and predicting outcomes without being explicit programmed. The basic premise of machine learning is to build algorithms that can receive input data and use statically analysis to predict an output while updating outputs as new data becomes available. And also, machine learning focus on the development of computer programs that can access data and use it to learn for themselves. And the process of learning begins with ob- observation of data such as examples, direct experiences or instructions in order to look for patterns in data and make better decisions in the future based on the examples that we provide. In fifth slide, there are 7 steps of machine learning. Step 1, gathering data. Step 2, preparing that data. Step 3, choosing a model. Step 4, training. Step 5, evaluation. Step 6, hyperparameter training. And 7th step is prediction. These are the 7 steps of machine learning. In next slide, we discuss traditional programming and machine learning programming. In sixth slide, we see that the difference of machine learning and traditional programming. First, traditional modeling. By the diagram, we can see that the traditional programming is a manual process, meaning a person create the program, but without any programming, the logic one has to manually formulate or code rules. In machine learning modeling, by the diagram, we can see that it can increase the value of your embedded analytics in many areas, including data prep, natural language interfaces, automatic outlier detection, recommendations, and causality and significance detection. All of these features help speed user insights and reduce decision bias. Unlikely traditional programming, machine learning is an automata process. In this slide, we discuss the type of machine learning. Machine learning can be classified into 3 types of algorithms. First, supervised learning. Second, unsupervised learning. Third, reinforcement learning. By the diagram, we can describe these 3 types of machine learning. First, supervised learning. Second, unsupervised, and third, reinforcement learning. And further, this divided into some parts. These are the algorithms. First, supervised learning. In supervised learning, prediction, classifications, and regressions real value. And unsupervised learning, clustering, probability, distribution estimation, finding association in features, and dimension reduction. Then semi-supervised learning. Then reinforcement learning. In reinforcement learning, decision making, robots, chess, and machine. In this slide, we learn about supervised learning algorithm. And supervised machine learning algorithm can apply what has been learned in the past to new data using labeled example to predict future events. Starting from the analysis of non-training database, the learning algorithm produce an inferred function to make prediction about the output values. The system is able to provide target for any new input after sufficient training. The learning algorithm can also compare its output with the correct intended output and find error in order to modify the model accordingly. In this diagram, we can show about supervised learning algorithm. In this slide, we learn about unsupervised learning algorithm. In contrast, unsupervised machine learning algorithm are used when the information used to train is neither classified or labeled. Unsupervised learning studies how system can infer a function to describe a hidden structure from unlabeled data. The system doesn't figure out the right output, but it explores the data and can draw inferences from data sets to describe hidden structures from unlabeled data. We can show in diagram the unsupervised learning different label and unlabeled data from 5 characters. In this slide, we learn about reinforcement learning. In reinforcement machine learning algorithm is a learning method that interacts with its environment by producing action and discovers errors or rewards. Trial and errors, search and delay rewards are the most relevant characteristics of reinforcement learning. This method allows machines and software agents to automatically determine the ideal behavior within a specific context in order to maximize its performance. Simple reward feedback is required for the agent to learn which action is best. This is known as the reinforcement learning. We can show in diagram a agent show a robot. First step is observe and second select action using. In third step, the robot perform a task and get reward. On fourth step and get reward or penalty. The robot get penalty. In fifth step, update policy learning step. The robot feel warm bad. Next time avoid it. Sixth step, iterate until an optimal policy is found. This is the reinforcement learning. In this slide, we can discuss about machine learning life cycle. And machine learning life cycle involves 7 major steps. First, define project objective. Second, data collection. Third, data processing. Fourth, data visualization. Fifth, model selection. Sixth, model building. And seventh, deployment. The most important thing in the complete process is to understand the problem and to know the purpose of problem. Therefore, before starting the life cycle, we need to understand the problem because the good result depends on the better understanding of the problem. In complete life cycle process to solve a problem, we create a machine learning system called model, and this model is created by providing training. But to train a model, we need data, hence a life cycle start by collecting data. This is the machine learning life cycle model. In this slide, we can discuss about some important points. First, define project objectives. Specify business problem requirements. And second, data collection. And data collection, primary data. The primary data collected by researchers from first-hand source. And secondary data. The secondary data collected by someone else and already been passed through the statistical process. And third, data processing. And data processing, data cleaning, and filling missing data, and data transformation and normalization, and dimensionality reduction. Now we can learn data visualization in this slide. What is data visualization and why is it important? Data visualization is the representation of data or information in a graph, chart, or other visual format shown in diagram, graphical representation of data. It communicates relationships of the data with image. This is important because it allows trends and patterns to be more easily seen. With the rise of big data upon us, we need to be able to interpret increasingly large batches of data. Machine learning make it easier to conduct analysis such as predictive analysis. We can then serve as helpful visualization to present. But data visualization is not only important for data scientists and data analysts, it is necessary to understand data visualization in any career, whether you work in finance, marketing, tech, design, or anything else. You need to visualize data. The fact showcase the importance of data visualization. Why do we need data visualization? We need data visualization because a visual summary of information makes it easier to identify patterns and trends than looking through thousands of rows on a spreadsheet. It's the way the human brain works. Since the process of data analysis is to gain insights, data is much more valuable when it is visualized. Even if a data analyst can pull insights from data without visualization, it will be more difficult to communicate the meaning without visualization. Chart and graph make communication data finding easier even if you can identify pattern without them. It undergraduate business schools students are often taught the importance of presenting data finding with visualization. Without visual representation of the insights, it can be hard for the audience to grasp the true meaning of the findings. For example, rating of number to your boss want to tell them why they should care about the data, but showing them a graph of how much money to insert could save make them sure get their attention. In this slide, we can discuss some models. First, model selection. Second, model building. Third, model deployment. First, model selection. In model selection, linear regression, logistic regression, random forest, k-mean clustering. These are the some parts of model selection. And second is model building. The model building is algorithm, train, test, model, and then prediction. This is the model building. And model deployment, model and deployment. These are the models of machine learning. In this slide, we can learn how to choose right machine learning algorithm. An additional requirement, type of problem, size of training set. The first step is accuracy. In accuracy, depending on the algorithm, the required accuracy will be different. Sometimes an approximation is adequate, which may lead to hug reduction in processing time. In addition, approximate methods are very robust to overfitting. Second step is training time. Various algorithms have different running time. Training time is normally function of size of data set and the target accuracy. Third step is linearity. Lots of machine learning algorithms such as linear regression, logistic regression, and support vector machine makers of linearity. These assumptions are not bad for some problems, but on other they bring accuracy down despite their dangers. Linear algorithms are very popular as a first line of attack. They tend to be algorithm simple and fast to train. Fourth step, number of parameters. Parameters affect the algorithm's behavior, such as error tolerance or number of iteration. Typically, algorithms with large number parameters require the most trial and error to find a good combination. Even through having many parameters typically provides greater flexibility, training time and accuracy of the algorithm can sometimes be quite sensitive to getting just the right settings. And the last step is number of features. The number of features in some data set can be very large compared to the number of data points. This is often the case with genetics or textual data. The large number of features can bog down some learning algorithms, making training time unfeasibly long. Some algorithms such as support vector machine are particularly well suited to this case. Below is an algorithm cheat sheet provided by Scikit-learn, which I believe it has implicitly considered all the above factors in making recommendation for choosing the right algorithm, but it doesn't work for all situations and we need to have a deeper understanding of these algorithms to employ the best one for a unique problem. This is the way to find a uh, right machine learning algorithm. Hmm. Now we can discuss advantage and disadvantage of machine learning. First, advantage. Easily identified trend and patterns. Second, wide application. Third, no human intervention needed, automation. Fourth, handling multi-dimensional and multi-variety data. And last is continuous improvement. And the disadvantage of machine learning are: first, data acquisition. Second, high chances of error. Third, time and resources are much more. And last one, interpretation results. These are the advantage and disadvantage of machine learning. So we can discuss about uh, some points of machine learning advantage and disadvantage. Now finally we can reach a conclusion. We have a simple overview of some techniques and algorithm in machine learning. Furthermore, there are more and more techniques apply machine learning as a solution. In the future, machine learning will play an important role in our daily life. It is a some little part of in this training of my conclusion, so I can learn some small things of machine learning, so I can express this experience of my training. Thank you, sir, for watching my presentation.